And good morning, ladies, gentlemen, cyborgs, interdimensional beings, whoever is here. Everybody is welcome. Okay, so first I acknowledge the traditional owners of this land, the Wajik peoples. I pay my respects to the elders past and present, and to Aboriginal peoples and elders from other communities who may be taking part in this live stream today. Now, just before, so on the subject of people, and good morning to everybody here. Hang on, let's see if this works. Just as I was getting set up, I think this microphone is hot. I'm going to turn it down a little bit. Okay, level should be a bit better now. As I was here this morning and making sure the microphone was charged and trying to clear a bit of space, all of that sort of thing, I had a video on which is a new one from Veritasium, and where are we? Yeah, so this was, I had this playing in the background while I was doing other things. What the longest running study on happiness reveals. So it's about several studies that were done over the space of many, many decades, tracking people through the course of their lives and the various factors and indicators that correlate to or correspond with happiness. So what is it that makes people happy? Is it money? Is it, all these different things? And I haven't watched all of it yet. As you can see, it's just part way through. But this is a really critical thing. This is getting towards the crux of the video, and it's talking about social engagement and how the single biggest indicating factor of health towards the end of life is the quality of relationships sort of through the middle portion of life. And in this analysis that we're talking about, if you examine people at the age of 50 and look at the quality of the relationships that they have, that is the number one statistical indicator of what their quality of life will be when they are 80, or how happy they're going to be, and those sorts of things. So this is just discussing the downturn of social engagement over like a 17-year period, while as part of this study as well. So anyway, the point of all of this is I just wanted to say thank you. So at the barbecue last weekend, I was talking to someone, I can't remember who, about how this whole thing came about. Or maybe, no, it might have been on the live stream. I really don't remember. About how these live streams came about and how they began at the start of the first lockdown here in Melbourne, when social isolation was really kicking in. It was when you weren't allowed to leave your house. So there was a whole lot less interaction. People were catching up with friends on Zoom and having weekly Zoom catch-ups and things, which is why I started the live streams in the first place. It was to have a chance to talk to people and interact with people, and the fact that we're still doing this years later is one of the big things that has positively influenced my quality of life. Interacting with all of you. So thank you very much. So good morning to Gavin. Some call it fun. Luminator. Amanda is here just for a little while. Okay, I was going to bring up the presence project. I'll talk about that in just a second. Henrik is here. Stephen. Keith H. Good morning, Keith. Intermittent is here. Rolves. Hello from cold Norway. Minus 15 outside. Johan is here. David, Austin, Russell. So where was I going? Brain misfire. I need a little indicator on my chair or something that is connected to electrodes, so that when my brain misfires, a light goes on. It would have just been flashing right then. I have no idea where I was going. That's right. Two things. So Mitchell is not here in the chat, unfortunately. He couldn't make the stream today, but he has set up the text-to-speech thing. So that is running. If anybody wants to say something. Lifeweeks, thanks for coming along. So I came into this with this particular live stream with no plan. Come on, say it. Waiting.
Austin's_creations said test.
Yes, the test worked. Okay, there was a bit of a lag, but it works. Okay, so right at the start, Gavin was asking about personal pre-shared keys on Wi-Fi and how that works. And the other thing is that I haven't talked about Amanda's Presence project for a little while. I haven't actually even been paying attention to it, to be honest. I'm sorry, Amanda. So I don't know if there has been any further development on that since. There is a dedicated channel for it in Discord, so presumably people will people will have been continuing to discuss that, but I don't know. So if there is an update to that document, I could have a quick look at that before doing the before getting on to other things. So Amanda, I'm not sure if you wanted to make that a bit of a topic for the start of the stream today or not. If you do, that'd be cool. Now, apart from that, so one thing that I really want to make progress on is the OpenKO board and this. Why isn't, no, not that, that's the CAN bus side. I was using this board for testing CAN bus during the week on another project. It just happened to be a board that was convenient because it's got an ESP32 on it with CAN. And I was experimenting with different CAN transceivers and CAN controllers and speed and all that sort of thing. So there's a client that I'm doing with, okay, update next week.
Amanda Thompson said no update on way to air show. We'll have an update for next week.
Cool, thanks Amanda. And have fun at the air show. You know, I've never been to an air show. There is a regular air show at just outside Melbourne, like just on the fringe of Melbourne. There's an airport. It's I don't know if it's currently a military airport. It used to be down at Laverton. There was an airport that was formerly an exclusively military airport, but I think they use it for like just commercial stuff now as well. And there is a regular air show there, and I've never been to an air show in my life. I'd like to go to one day. Avalon. Yeah, Laverton? I said Laverton. Isn't there a... Yeah, so Avalon is one airfield. Laverton Airfield. I think, yeah, Laverton is the RAAF base. Yeah, base, it's Base Williams is at Laverton. So that's the, oh, Tyab Air Show on in March 2024. Tyab. Down around the bay a little bit. Okay, Keith, maybe we should organise a trip to the Tyab Air Show. I'd like to go to an air show. I don't know why that I've never been to one. I think it's basically because in my head I think the planes doing stuff are up in the air. You can't, you can only see them from a distance, so what's the point? But I don't know. I would like to. I'd like to one day. Yeah, so anyway, I pulled this board out just before the stream and I was looking at it, and there are patches on this board around the USB hub, and it made me realize I don't remember what we did to get the USB hub working, because my memory is notoriously bad. In fact, I'm going to, let's see, I'm going to see if I can pull up, which button do I press? The projects button. Okay. OpenKO. I've got some notes in here. and I don't remember if I made notes to myself or not. Hang on, got to move that out of the way, move this up to here, and then we can see what's going on. Okay, so to do, set strapping pins.
Austin_creation said I do, and so does Scott.
Haha, nice. So I have outsourced my memory. Okay, so there were some strapping pin changes.
Amanda
And
Thompson said it's not just the air display, it's the static display and technology.
yeah, I think that would be the interesting thing, being up close with the different bits and pieces, seeing, checking out the aircraft, and I presume not just aircraft. So when people say air show, the obvious thing is to think about it's all about the aircraft themselves, but there's got to be stuff beyond that. The aircraft is just the little thing that flies. There's all of the infrastructure around it that I would find really interesting as well. A whole lot of the technology related to it. All right, so I need to check these strapping pin things. Switch serial 2 pins to 1 and 2 as per patch prototype. Okay, so that was a change on the serial. CAN bus is good. There were, on this prototype, I can see there's a capacitor patched on. I have a feeling that what we did was isolate the reset lines and then put I put a capacitor on. Just looking at the size of it, it's probably like a 10, yeah, could be a 10 microfarad capacitor on the reset line for the USB hub. Oh, Celtic Bee says Point Cook has an air museum in Victoria. Yeah, that could be an interesting thing to go to as well. And Austin said, while the tech around aircraft is cool, I've always been more fascinated with trains and switching systems. Yeah, trains are cool too. Right, so I think that what I should do is, even though this serial is not yet fully validated, I should apply whatever other changes have been made to this design to the board. Otherwise, I am probably going to lose track of it and not be able to not be able to get it working again. So maybe that's the thing to do on this stream. I can start by applying some of these patches, and then I don't know. I do want to check what's going on with this serial. The thing is that if this serial change can be made to work, then these boards could go off to production, because the rest of it is kind of secondary. That's the important thing. Yep. Austin says USB hub had reset isolated and a setting pin needs to be changed to select 2 versus 3 ports. Yes, that's right. Sion! Moo! You made it along. Okay, so no, not that. That's a client project directory, so let's not look in that one. I'm going to bring up OpenKO. This is better. Bring this up. OpenKO. Oh, I should put it all in a folder. All right, let's do this. New folder. OpenKO v10. Now, I'm going to take a bit of a strange. Let's see. Can I move these as a group? I believe I can. OpenKO. I'm going to put them in OpenKO 1.0. Okay. So now I'll have a subfolder for this project. Now, the versioning. So my preference is to use Git for versioning as much as I possibly can, including hardware design files. And with Eagle, and I'm pretty sure KiCad does this as well. So in Eagle format files are JSON files. JSON, no, they're XML. I can't remember. Anyway, they're text. They're some kind of actual readable text format. And I'm pretty sure that KiCad does the same. It uses some kind of a text format. It's not like a nasty binary format. And that means that you can diff them and do interesting things like that. Yeah, getting Tiny C6. Oh, and the watch. Yeah, Sion's working on some really cool projects at the moment. And so because I've been using Fusion recently instead of Eagle, I've been doing this kind of dodgy thing. So let's do this. OpenKO. This is very let's go back one level. This is a very kind of dodgy, it feels like going back to the 80s in terms of revision control, but I actually keep folders with the different versions of the project in it. And that means that I can, and yes, I know Fusion has versioning sort of thing built in, but it's terrible. I don't want to use it. So rather than export constantly and then store the files externally and then import them and all of that sort of thing, which is what I probably should be doing, I've gone back to the 80s and I make a folder. So if we come into here and I'm going to go new, this is my process for making a new revision of a board. I make a new folder with the new value, like with the new version number, and I'm going to make a new OpenKO v1. So we make a new empty electronics project. So this is an electronics project, but it's got no schematic and no PCB associated with it. And save it as like an empty shell. And we click on link to a schematic, and then we go back and find the schematic from the previous version, and you have to click create a copy. So don't reference it, actually copy it. And that will take that schematic from the other project and pull it into this one. And then I'll go back to here and I'll also link a schematic. So go back into the previous project and make a copy, select, and bring that in. So now we have a new electronics project with the schematic and the PCB imported from the previous version of the project. So now I'm going to hit save on that, give that the version number in its name, and save. That applies that same version number to both the schematic and the PCB. And now I'll get rid of that dummy project, and now we have an electronics project with a schematic and a PCB, which have both been directly derived from the previous version of the project. And it's been saved at this point. So this save point, the first save of the project, is the point at which it was the same as the previous version of the project. Yeah. Yes. So, oh yeah, I am going to be using KiCad for the AP project. So when I get back to that, that is definitely going to be a KiCad thing. And also the boards that I'm doing for Dick Smith's Fun Way into Electronics, I did a few of those in Eagle a few years ago, but I'm going to redo them in KiCad. Also, is anybody internally screaming when I say KiCad instead of KiCad? I actually really don't care. It's just, at some point I ended up calling it KiCad and other people call it KiCad, and I don't know. What am I doing? Okay, so here we have OpenKO version 1.1. So I'm just going to get rid of the document panel, and let's make a couple of changes. Yes, yes, legacy layer names, go away. Now let's make a couple of changes here. Oh, this layout system, this panel system is so annoying. But I had to do this in order to move stuff between sheets. What have we got? There were no changes required in the voltage regulator section were there, so that can all stay the same. What else do we have? CAN bus interface is all good. That's been validated. We know that's fine. The KO serial interface is going to have to change, but I will get back to that. So the display, this is going to have to change because of the strapping pins. So those strapping pins are going to have an effect in various places. We've got piezo beeper, we've got status LED on IO46. Did I ever get that working? I can't remember if I validated that or not. I just don't know. There's the quick connector. That is probably going to have to change because that's got the I2C pins on it. So I need to come up with new pins for I2C. Cap on microcontroller as well. And 3, 2, 1.
Austins_creations said cap on microcontroller enable as well.
Yes. So let's start doing a couple of these things. Microcontroller enable, which is this pin here. At the moment it's got a 10K pull up, but we also want to pull down. So let's just move a couple of things out of the way. This is the USB data positive and negative. Oop! Stop with that crazy zoom. Stop it! Stop it! And snoot, where can I, just wondering the neatest way to do this. Where am I going to stick this pull down? And what do I want to use? It's 100, maybe 1 microfarad. I think that's probably the thing to do. Where is do we have any other caps on this sheet? No, we don't. Only an 0805 cap. That 22 microfarad is 0805. So let's grab, oh, stop that. I'm trying to scroll in the list. That's better. Now it's working. Superhouse capacitors. Cap 0603. Yep. Stick it. This is an ugly bit of circuit. I don't like this. I don't like it. Don't like it at all. 1 microfarad. Let's
Austins_creations said I use 1 UF in my designs.
Yep, cool. Thanks, Austin. Good to confirm. But look at this chunk of layout here. This is horrible. I don't know why, but this kind of offends me. The fact that there is this cap inside this loop with a ground in here, which is not below this trace, and it's just all sorts of bad. Maybe what I could do is put another ground here and move the snoot button. Let's do that. Just to try to make this slightly less offensive. Bring this around here somewhere. That's ugly too, but I'll fix that in a minute. Yes, and I know there are 2 grounds next to each other. Let's get rid of that and that. And move... where can I put this? Out there somewhere. I've got to bring this one up here and join it to there. Oh, it's still so ugly. I've got to move that in there. Well, yeah, that reset button symbol really needs to be fixed. I don't like the fact that it's got the 2 tabs coming off the side. It kind of follows the physical layout of the switch, but the logical layout doesn't need to be the same as the physical layout. So yeah, and these grounds being up here near these 3.3 volt supplies, oh, that breaks my mind as well. Alright. Oh, but these are probably going to have to change anyway because we're going to be changing the I/O pins. So technically this should be correct right now. It's just not pretty. I think it's probably slightly less ugly than it was before, but not by a whole lot. Let's move. Nah. Yeah, that switch has been mirrored left to right. Why was it mirrored left to right? Oh, I think it was just so that the pin would come out the correct side for easy routing. Does the switch need to be horizontal, asks Celtic. That's a very good question. I don't suppose it does. It's just that it never even crossed my mind to make it vertical. That's a really I don't know why. This is weird. The reason my brain is misfiring so hard right now is I don't recall ever having look at how these traces are rubber banding. That makes no sense at all. I don't recall ever having a vertical switch in any of my schematics. It's like it just never even crossed my mind that it's possible. Just use a label and move the reset circuit somewhere else, says Stephen. Yes, but no. Yeah, I know what you mean. I prefer when, hang on, I need to cough. I've had this weird thing in my voice since I started the stream. Oh, it's probably no better. Okay, maybe a swig of caffeinated beverage. Celtic says the 2 on top of the 1 would be playing with your OCD. Yes. So, all right. Now, in terms of using labels and then linking out to other parts of the circuit, yes, I do that fairly often. Like you can see here, for example, the display is in its own self-contained block and it's got the I2C connections to it just coming off with labels. And same with the quick connector, even the same pins. And putting these right near the microcontroller up here would make it really cramped and it'd be very awkward to get the layout to work. So I do break those out into their own little subsections. But also they are kind of conceptually separate to the microcontroller. There is the microcontroller and all its directly connected things, the things that it needs to work. And then there are subsystems that are not directly part of the microcontroller and its support circuitry. So I kind of try to keep it logically grouped. Yes, I could take this reset circuit and stick it in its own, just move it somewhere over here or wherever, it doesn't matter, and move everything else to the right. And then have a label saying that's a reset, and then have a label on here saying that's the reset net. But and if it was much more ugly than this, I would be inclined to do that. But I prefer to keep the things directly that control the microcontroller, like connections to strapping pins, connections to reset, all of those sort of things, in physically connected so you can actually see. You don't have to go searching through the elsewhere on the schematic to see what is on that net. It's not a hard and fast rule, it's just generally the way I try to do things. So if you're looking at the microcontroller block, like if you, and also I tend to reuse blocks a lot between circuits. So if I wanted to take an ESP32S3 on a Vroom module with its associated circuitry, I would just grab this whole block and then move it into some other project, copy and paste. Okay, so back to changes. All right, so what we've done is we've added the 1 microfarad pull down on the reset pin for the ESP32. We also needed to split the... yeah, I'm not doing this in a an orderly way. I haven't reset this one here. I have not made myself a change list. So let's bring this one. Oh, why can't I move it there? That rubber banding is not good. Let's move it there, and then let's rename this net. So this one, what do we call it? Just this segment, because I want to do I want to dissociate this particular net from the rest of the reset circuit. So that I've pulled off, and let's stick on. I'll just copy this one, stick it on, change its value. So I'll make that one 1 microfarad as well, and link that to USB reset. Then we need a ground. Okay, so that should take care of that, except now we need a pull-up. Let's make a little bit of room for ourselves by moving this down here. There, does that work? I think that'll just about work. It's kind of getting tight in there, but it'll do. And then, do I have a 10K resistor nearby? No, I don't. There's a 15K. Doesn't matter. I was just wanting to grab a footprint anyway. So I'll stick that there and change its value. Could use 15K as well for consistency. I've got 15Ks over there. I don't know why, I just tend to use 10K for bias resistors. And we're going to pull that up to 3.3 volts. And it's going to come up over there. There isn't enough vertical space to totally enclose it, so I'm going to move it up to there. Or I could reverse that. What I could do is put that part of the circuit up here. Yeah, no, I think it's okay. It's kind of ugly, but it's functional. All right, so the USB hub now has its own... Oh, okay, Celtic says move IO3 4 traces and resistors down. Where is IO3? IO3? For more room. Is IO3... Is this talking about this part of the circuit or the bit that I was messing around with earlier? And 4 resistors down. Okay, no, I think... Oh, previous. Cool. Thanks, Celtic. So, sheets. Come on. Sheets. How do I scroll in sheets when I don't have focus in here? See, scrolls there. I want to scroll sheets. Okay, there we go. Scrolling sheets now. Takes a while for Fusion to figure out that the focus has changed. Move caps down. IO3. Where was it? Move IO3 4 traces and resistors down for more room. Yes, yes, I see what you're saying. Right. That would have been sensible. But the thing is that IO3 and 4 are about to change anyway, I believe. So let's change... let's change... Oh, now it's scrolling the sheets when I want to be scrolling the canvas. There, now it's scrolling the canvas. Oh, Fusion, I am growing to hate you so much. Okay, so IO43, these, we want to change TX and RX from 43, 44. They would normally be... Celtic Beast says having grandkids pull-ups have taken on a whole new meaning. Yes. Yes, they keep the mess where it needs to be. Some call it fun. Ugly but functional. I've been called worse. Yeah. I don't think I qualify as functional. So I don't even get that. I don't even get points for being functional. So, all right. Here we go. Look at this. There was a to-do list in here after all. Okay, so USB hub pin 24 to pull down instead of pull up. Okay, I'm going to go through and actually do the things on this list. So 15K pull up and 1 microfarad pull down on hub reset. Let's 1 microfarad pull down on ESP32 reset. Let's mark them off. All right, 1 microfarad pull down on ESP32 reset. That is done. So, stop it. I'm trying to scroll in here. There. 15K pull up and 1 microfarad pull down on hub reset. I put on a 10K pull up, but that doesn't matter. Isolate hub reset, that is now done. New pins for I2C. Let's change LED pin on GPIO 0, which is, I believe was Austin's suggestion from a couple of weeks ago, and that is a really nice thing to do. So I've always avoided GPIO 0 because it's dangerous. So the snoot button right here on GPIO 0 sets boot mode, and yeah, I have always treated IO0 as do not touch, like danger, here be dragons. And so let's change, let's change this, IO46, every segment on this sheet. Where else is IO46? It's probably only, stop it, Fusion, zoom in the right place, there. IO46 LED. Let's, stop that. Let's get rid of that, and I'm going to stick a no connect symbol on that pin, and then now if I change this, it should only have, yeah, that was it. So that was the only place that that net appeared. So let's change this to IO0. Hang on, what is it called? IO0, what is that net called then? Maybe there, it isn't even named. No, $21. So let's name that net. We'll name that net IO0. IO0. Should I call it IO0 LED? I have a feeling that I should. And I'll stick a flag style label coming off here to show what that net is. Let's move that there and there and there. So I want to include LED in the name because it's kind of a special purpose thing. Otherwise it won't be obvious that IO0 is doing anything except being IO0. So I'm going to rename this one and match it to that net. Yes, connect. And so now the LED should be connected to IO0. All right, did I patch that on the prototype? I have a feeling that I didn't. I think we just talked about this, but I never actually did it. And using IO0 for a status LED is a good thing because it means that it's not taking up an IO pin from something else that could be making use of it. So I think in future I'm going to follow Austin's lead here and default to using IO0 as the connection for a status LED for a WS2813 or similar. That is a cool thing. Alright, so where is my to-do list? LED pin on GPIO0 is now done. As far as the schematic is concerned, of course, this is going to be totally screwing up the PCB layout, but that is a problem for later. Okay, so USB hub pin 24 to pull down instead of pull up. Jolly good. Where is pin 24? 24, where are you? 24, there. Okay, needs to be pull down instead of pull up. Okay, not a problem. Let's move that to there, and we will disconnect pin 24. NP3, so just to check, is NP3 the, NP would be number of ports. NP3, number of ports 3. That's my guess. Okay, so NP3 is now pulled down to ground. And what else do we have here? Bus power is high. Yeah, okay. So that should be all we need to do to enable that extra port. Did I patch that on here? I did. Okay, pin 24. Yeah, I've got a little patch on the PCB. Alrighty. Stephen says, to do is missing the UART pin change. Yes. It is, but it definitely needs to be done. The UART pin change. So, okay, so that's the USB hub enabling the third port. Why? I don't understand why that would default that way. Anyway, what am I doing? Back to here. Okay, USB hub 24. Yes, we've got to remember the serial. Now, the thing is that the serial still is not validated. All right, that is done. And LED on pin GPIO 0 is done. So new pins for I2C. 4 is SCL, 5 is SDA. What did I have it on? Was it 3 and 4? I can't remember. Yes, I had it on 3 and 4. So 4 for SCL, and what is it currently? Okay, so 4 is okay. All I need to do is move from 3 to 5. And why is there a no connect symbol on that pin? Let's get rid of that. And this one, let's change this, and I'll do a little bit of rearranging to make it neater as well, because I want that one below that one, bring that one down there. Then we can bring this net up here to 5. And then I've got to rename this. So we'll rename every segment and we'll make it IO5 SDA. Now, does that match what the note says? So it says 4 for SCL, 5 for SDA. And that looks acceptable. I think that might be all right. I'll just move these across a little bit. Give it a little bit more room. Come on, select. Oh, why did you drop the select tool? Oh, why can't I select you? Ah. Stupid. Okay. So 4, 5, and let's just do a quick check. So we've got 4 and 5 on the display. The quick connector has 4 and 5. And I think we're good with that. I'm pretty sure they were the only things that were on I2C. Oh, David, you made it along. With flames and fires and smoke and life? What? What has been going on in your life? Flames and fire and smoke. Have you been off firefighting, or have there been fires near you? Let's see. Okay, so before I get into the, where are we? Okay, so new pins for that. That's done. I'm going to now edit this to-do list, and I'm going to say change UART pins. Pins for KO. All right, that is still to be done, just to make sure I don't forget it, because it's kind of important. So let's just validate this. This note was added after comments in the chat a couple of weeks ago. So IO0, I just want to make sure, because this is the definitive list of the strapping pins and what they need to be set to for the S3. So IO0 is set to a pull-up. Check. We have a pull-up on IO0. IO3 needs to be floating, which it currently is, which is good. 45 and 46 both need pull downs. All right, so 45 and 46, I have a feeling that they have weak pull downs or something by default, and so they don't actually need to be pulled down. But I may be wrong. I can't remember. Oh, a metaphor. Okay, so David has not literally been fighting the chemical reaction known as fire. Stephen says you don't have to put pull downs on them. No, cool. Yeah, that's taken care of on the module, I believe, on the Vroom 32 S3 module. But it's just important that we're not using them for anything. Okay, so we've complied with the pull down requirements, and CAN bus we've validated. We know that's working, and I even used it on this board during the week when I was testing something else. Austin says no pull-ups or downs needed for RX and TX. Yep. Henrik said also, what revision of the board is it, like 5 already? No, this is only the second one, because I've only fabricated one board. This was version 1, and all of the testing and modifications and things have been done by physically patching this board. This has bodge wires on it, and it's got tracks cut and extra parts added. So most of the changes that we are doing in the schematic right now have already been done physically on this board, just as a validation process. Nosson says, but I would change the TX and RX pins for KO-TTL to avoid the bootloader messaging causing trouble with the KO. Yes, the TX and RX, that's right. That is definitely the change that we still need to make. That is this change right here. And I patched it on this board. So those orange wires that you can see are the patch wires for TX and RX. Now, what did we do? Celtic B says bodge wires equals production model. Yeah, so what I did was I patched from 38 and 39, pins 38 and 39 across to TX and RX because they're right nearby. So which way did I do it? Oh, it was shifted up. So 37 got moved to 39 and 36 got moved to 38. However, this is the thing where we need to figure out the TX RX flip because I think I've been using it backwards all along on my hacked up Rack 32 board. Now, where are we? 36, 37. Where are those other pins? Where are 38, 39? Over here. Okay. So I'm going to take this. Yeah, so we're using IO1 and IO2 now. Come on. Select it. Select it. Why can't you select it? Oh, and then dropped it when I moved it. Net. Let's stick a couple of nets on here, and yeah, I'll just put labels on them for now, even though the nets aren't set properly. So what we have to do is figure out which really is the TX and which is the RX on the KO. And of course this can be swapped in this can be swapped in software, but it'd be nice to have the labels being correct. I'm beginning to wonder if I have lung problems. Oh, stretchy, stretchy. Austin says, open the Arduino sketch and show the begin. Yeah, but this is the thing, is that we haven't actually even got this working on the KO yet. We've only got it working on the with the USB to serial converter plugged into it. Dustin, hey, thanks for coming along. So I'm going to yeah, save it. Yes, okay, so I believe the final change is routing TX and RX up here to pins 38 and 39, which means that the final routing change is trivial. It is just moving this track. There's nothing else around it. There's plenty of room. It is super, super easy. So what I could do is, while I'm here, what air wires do I have to route? Okay. Oh, why can't... yeah. Frustration 360 is right. Okay, so IO0. The LED needs to come through to IO0. Looks like that used to go... Oh, that used to go somewhere else. Where is that going now? Up there. Oh, that's convenient. So let's just get rid of that and route... what am I going to route? 3048. That'll do. No, let's go 254. We'll go a 254 trace, and I'd like to move that just a fraction, maybe to there. Now hang on, does that go through? SEL, I have a feeling there's an overlap there. Oh no, that's correct. Why is... Oh, of course, because that didn't even change. SEL was always on IO4. It's only SDA that has changed. Alright, that goes to there. We've got a ground to there. Why is there an air wire on it? It's because there isn't really an air wire on it. Then we need to get that across to there. Alright, let's get rid of some of these visual noise layers. That'll do. Oh, what? Okay. I need to get that track through to there, which is going to be kind of annoying because I've got this one. Oh, that doesn't even need to be there anymore. Ah, because these resets are not tied, which means I should move stuff up to there. So the reset circuit for that goes to that. Okay, this is good. It saves this whole interconnect that runs all the way across the board here. And it lets me route a track across the bottom of the board. Go and get rid of all of this. Yeah, so now I can run a track across the bottom of the board for this, which is better. Much better. Let's go... In fact, I could just do it from over here. Yeah, this will work out much neater. We'll take a track from here to here, duck it to the bottom of the board, bring it along here somewhere, up to about there, back to the top of the board. Can I get into that corner? Yes, I can. And those wires are too big, let's make them smaller. Okay, so that problem is solved. What have we got? 6 air wires. And we've got a few random parts that need to be thrown on the board. What is this one? That is a 1 microfarad cap, which I think has to go up here next to the, that way, somewhere up there. Anyway, it's got to go parallel to this. I'll figure that out later. And then these two are part of the, they are the pull up and the pull down on the reset line to the USB chip. And there's heaps of room, so they can go in there somewhere. Well, when I say heaps of room, how am I going to get that track through? That's kind of annoying. Where did the track go before? Maybe I'll have to shove this in and take a wire from there, but I don't want to have to do that. I might move these instead. Yeah, let's move these instead. Come on, give me a move tool. Give me a move tool. Give me a move. There. Okay. And do the same for this. And that, and move that over there. Yeah, a little bit of symmetry. That's good enough. Then, what have we got? That one, why is that going to there? Oh, I see. So what I can do is take that to there, that to there, and that should be reasonably neat in terms of routing. Oh, yeah. Okay, that's cool. Let's route it. And then 3.3 volts to there. Do I really want to? Yeah, okay, stuff it. I'll do that. Not the neatest routing job, but it functions. One air wire. Okay, that'll be back up here because of this one. Now what do I want to do? Maybe, yeah, where does reset go? Maybe I'll just chuck it over the other side of the board. Yeah, stuff it. I'm going to move that. I'm going to put that cap way over. Oh, pick it up. Why won't the move tool pick up the part? There. Yeah, let's just stick it there. That'll do. Route that to there. And then I believe we are done. Nothing to do. 0 air wires. Okay. Hit a save on that point. And then, okay, so the next thing is, and the final thing, is resolving this whole problem with TX and RX and which one goes to which. So, oh, Iggy, you made it. Does this mean that you're not lying on a beach anymore? You're not lying on a beach, and you're not on like the 700th floor of a penthouse suite looking out on a view of a city, and you're not, what was the other thing that you did? Ah, oh, that's right, there was some really nice old hotel. You're hanging out with us instead. Yep. Where are we? Yeah, TX and RX. Okay, so okay, I'm going to rip these tracks up because we know they're wrong. We just don't know what they should be. And at least that way, by having them ripped up on here, they're not misleading. I know that that is a dangling task that still needs to be completed. So we now have 2 air wires, which are just TX and RX going to the KO. So the next thing to do, I think, is figure out what, to the best of our ability, what the TX and RX should be. So, yeah, and Austin says, well, the bodge is in place. Why haven't we retried the KO connection? I did try the KO connection, but I probably had TX and RX reversed. So there are 2 things at play here. One is we can make it work, and 2, how do I explain this? What I want to know definitively is on that little 3-pin plug that comes off the KO, which one is TX and which one is RX from the KO's point of view. And I've got it working with the rack 32, but I believe the rack 32 has the connections reversed in terms of the labels being the opposite of what they are. So, yes. All right. But I think both of those things can be answered by putting the board in place, connected to the KO, and try to get it communicating using, basically by playing around in software. Like we can switch TX and RX in software, see which way works. That then tells us which is the TX and which is the RX. So it's kind of a backwards way of doing it. It's instead of working on the basis of this is the TX pin and this is the RX pin, it's working on the basis of just try it, see which one works, and now we know which is the TX and which is the RX. So I could give that a shot, I guess. Gavin says, so putting 2 probes on a scope and watching what one sends a signal on TX won't confirm the pins. It probably would. Getting a scope in there is the issue. I've got a portable scope. The thing is that a lot of this stuff is really hard to do on a stream because it means getting a camera or something in there. It means getting test instruments in there. Okay. So, all right, what I'm going to do is on this project, I'm going to put the connections in place the way the bodge wires are currently done on this board, so that what is in Fusion up there will represent reality. And then we will check reality and see which is TX and which is RX. So if I come back down to here, we've got so 36 and 37 need to go to 38 and 39. So what I'm going to do is name these nets something sensible. So 38 is going to become, well, we'll say IO38. And for now, I'm going to say that it is TX. And 39, I'm going to say it's, no, it's not IO38. It's IO2. It's pin 38. What am I doing? Okay, so pin 39 is IO1, which is RX. And this should be IO2 as TX. Okay, so this, so pin 36, which is RX, becomes 39. No, I got that backwards. Iggy asked, do I have any concerns about the signal integrity of those long interrupted USB lines, etc.? Not trolling, just channeling Robert Ferenac. Or is it greater than 2 layers? No, it is only 2 layers. And I believe, on this one, did we do the matched pairs? Yes, we did. So these USB lines are impedance matched. But you're right, they are long and they are interrupted. They come through, they're on the bottom of the board, they come through this filter into data plus and minus on port 0 of the USB hub. But yeah, they travel all the way from the USB socket here, across the board, and then up to here. So yeah, I don't think signal integrity is going to be too much of an issue. It's a reasonably small board. That's actually not that much distance to travel, and they are a match. They were routed as a matched pair, so they're impedance matched. Well, they're length matched, I should say. Yeah, so where was I? That's right. I was just proving that I, once again, was getting TX and RX backwards. This stuff, I don't understand how it's so hard, but it always is. Okay, so pin 36 is going to go to pin 38, so that's RX. So that should be IO2 is RX, and this should be IO1 as TX, which we may have to swap back again, but that's currently what it says. Hang on, just checking. So the bottom one goes to the bottom, top one goes to the top. Yes, just looking at my patch wires on the PCB there. All right. So we'll chuck the no connect pins down on here, and that should be it, I believe, for the schematic. So now, why? Oh, I know why. So IO1 TX, where is the connector? Where's the connector? KO. There. It's because I didn't rename these. IO1 TX. Yes. And this will be IO2 RX. IO2 RX. Now the air wire will be back. Oh, I reflexively hit save constantly just because I don't know, it's just a habit that I'm in. Alright, so let's bring this one up here. And this one up here. And now we should be done. Should be 0 air wires. And there are 0 air wires. Now, was that someone just pinging me in? No, it was someone pinging me in Mastodon. That's okay. It wasn't Discord. All right. That board, assuming TX and RX are correct, then that should be fully routed. So I will hit save now. So the next step then is going into firmware, open KO, firmware, and let's see what we've got. So yeah, I think the next thing really is to plug it into the machine and see what comes out. See if we can get any data coming out of the KO, and try with both orientations of the, no, that's not what should be showing on there. Not that. Okay, here we go. KO. All right. Where is the config? CAN bus speed. No, I don't care about that. Actually, I'm going to set that to 250. Not that we're even using CAN bus right now, but I will probably end up using J1939 messaging format on CAN, so I'll be running that at 250 kilobits a second. So where are we? Okay, this is the important stuff. So I've got TX as pin 1, RX as pin 2, but of course the ambiguity is when it says KO RX pin, is that the RX pin on the KO, or is that RX pin that receives from the KO's TX pin? Oh, who knows? Who knows? So TX1, which way around did I have it? TX is 1. Okay, so at least now the config matches. let's try. Oh, so is CAN 4 and 5? I should enable that in the config anyway. Where is CAN? CAN is, CAN TX and CAN RX. Okay, so TX is 16, RX is 17. TX is 16, RX is 17, and let's just include that. And yes, I know this is not what we care about right now, but I might as well get it right while I've got the schematic open and I can reference it. Now, I2C, did that change? Yes, we did just change I2C, didn't we? So let's fix that while we're in here as well. 4 is SCL, 5 is SDA. 4 and 5, so 4 is SCL, 5, yeah, 4, 5. Okay. Get rid of that. All right. Oh, I see why. Hang on. That's why I had that commented out. It's because it was the same pins that we used previously on TX and RX on the rack 32. But that doesn't matter for now. I'll just leave those defined. If they're not being referenced in the code, then who cares anyway? So now this should, I think, be what we need. All right. Where's my USB cable? Got to plug in USB and we'll flash it. And maybe do a test. What is the time? 11:15. All right. It'd be really cool if we finish this with the board working. I wasn't really expecting to even try this, but let's give it a shot. So what have we got? S3, CDC is enabled, port is that one, and go. Is the machine running? No, the pick and place machine is not currently turned on. While that is compiling, I'm going to grab the tripod and see if I can get the Droid camera working so we can get out there and try it. Right, got the tripod. Where's my phone, my Android phone? There it is. So I'm going to find Droid cam. Okay. And now I can take you for a walk. Droid cam. Nothing is connected to Droid cam yet. Although if I bring this over here, aim that up there. Oh, okay, so we've got the code loaded. Now, does the phone work? Let's see. Come on, there we go, yes. Okay, we've got the phone working. What do I need? I need this. Trying to figure out what I'm doing. Okay, I gotta unplug that. I don't need the CAN bus connection. I don't care about the USB ports. I want the serial connection there, and I want that to the computer. So let's go for a little walk. Past the geckos. And down about there somewhere. Let's get this machine running. Okay, so I've got USB at the moment coming from the rack 32. So I'll just unplug that. So I'll leave the rack 32 unplugged. This is the serial connection coming from the KO. So I'll put that into this with the patched TX and RX lines, and USB into there, and sit that somewhere that it's not going to short anything out. That'll do. And now, whoa, let's see what we can figure out here. Oh, I've got that problem again. The USB hub is freaking out. Yeah, this machine is so flaky. I don't know what's going on with this. Do I have a... Nope. Oh, I don't have a keyboard either. Okay, I'm going to unplug the USB hub, plug it back in, and then I will get keyboard... No. Oh, yes, I do. I've got the mouse and keyboard back again, temporarily at least. No, I do not want to do a software update right now. Okay. Now, if I go to machine setup, G-code driver, what ports are available? Is it USB 1? I don't know. Actually, this is a... Let's test this. So we've got S0, ACM1, ACM0, and USB 1. I'm going to unplug the OpenKO board, and we'll see which port goes away. Okay. So ACM1 it must be. That's not the one I expected. So is ACM1 back now? Yes, it is. Must be that port. Okay, apply. Now, can we connect? This should open a connection to the thing. Okay, I'm going to risk it all and just hit home. Oh, it's working! Can you hear that? Check this out. The machine is homing. It just homed the conveyor, and if you look up there, it's homing the nozzles and the head. Oh, success! That was the first ever successful run of the OpenKO board controlling the machine. Wow. Okay, it's perfect. Send to production. I feel like there should be, I don't know, champagne and confetti or something after all of this time. All right, I'm just disconnecting it there. So I've just turned off the connection from OpenPNP, and we'll unplug it here. Or do I even need to unplug it? I could just leave it there. I mean, I could be using this board now to run the machine. I mean, why not? So, okay, that means that, yeah, I was kind of joking about it's perfect, ship it, but it means that I can ship it. Oh, got to get through this little gap. Come back over here. And switch back to here. Whew, okay. Now, what is going on in the chat? Scott says, make the KO act like a charm high and it'll provide the confetti. Yes, it would. Yeah, okay, so I've missed a bunch of the chat, but let's see. So header pin labels. All right. Iggy says, I know we all do it, but it was worth thinking about the broken return paths on the other side. Yes, that, okay, let's look at that. So this is a very important point. What am I doing? That. All right, so the point, I don't know that I'm going to explain this very well, probably not. There are many people who do really interesting videos about this sort of thing. The whole thing about where is the energy, is it in the trace or is it in the field around the trace, and where is the return path? Okay, so when you, how to explain this? All right, if we have, electricity has to travel in a circuit. Now, we use the word circuit kind of as a throwaway thing, but it has an actual literal meaning that is really important. And we do have to remember that a circuit is a circuit. Electricity doesn't just travel from one point to another. It travels back around as well. So as an example, look at the path of this USB-P trace right here. So this is the positive differential trace on the USB connection. So say electricity is flowing through this, and I'm going to totally ignore the difference between conventional current flow and, you know, actual physical current flow. Ignore all of that, it doesn't matter. The point is, imagine we've got electricity flowing from left to right in this wire along this positive trace to this location and down to here, and it is then flowing on through that resistor and so on through the circuit. Now, the electricity has to flow back the other way as well. So what happens is that there will be a flow of current left to right along this trace. There will also be a flow of return current right to left, taking whatever path it can that is trying to be close, because it is electromagnetically coupled. It is going to try to be close to the path that is going in the opposite direction. You can think of it as being kind of like north-south magnets. They want to be close together. So the return current going in the opposite direction for this trace is going to start off happily enough right here. It's going to follow along the other side of the circuit board. So it'll be on the ground plane on the top, either on the bottom or the top side of the PCB. In this particular case, there will be some return current probably on the bottom of the PCB running along in the ground plane that is beside the track, and there'll be some current on the top of the PCB running along on the ground plane that is opposite the track, so separated by the fiberglass PCB material. But you can see here there is a 3.3 volt rail that runs perpendicular. It bisects the signal path. So what happens is the current will be flowing left to right on the bottom of the PCB. The return path is going to come along here, trying to follow the the location of the track, but it can't get through this point. It's been bisected. So where does it go? It tries to bypass. But look how badly bisected it is. It can't get through anywhere here. It's blocked all the way along here. If I highlight that 3.3 volt rail, it is blocked from here all the way around in this big C shape around here, and down to here. So instead of the return current flowing along this point, you can probably hardly see my cursor, can you? Instead of it flowing above that track, it's going to have to go in the opposite direction, come all the way down around here, around the bottom of this pad, come back up here, and trace through, probably through here, under these parts, and then back up there. So there is a a big loop. The current is going in a loop and it is not staying parallel. So that's not great. Yes. The signal isn't, yeah, Iggy says, the signal is in the field between the layers, e.g. ground and USB. Breaking the return by putting traces across the path can cause those signals to radiate or couple to others. Yes, exactly. So this 3.3 volt rail here is a direct break across both the USB positive and negative tracks, which is not good. Now, one thing I could do, which is probably a good idea actually, now that you've pointed this out, is I'm going to put a ground wire right here, and then I should put another one right there. Or there and there. Yeah, let's do it on the outside. I mean, I know this is one of those things where it's not necessary to make it work, but this is kind of good practice. So let's just do this. Let's stick in, just to be lazy, I'm just going to copy one of these. No, that. I'm going to take that ground wire and stick it right there. So what this is going to do is have the effect of stitching the two sides of the PCB together. So this wire here is a ground wire. There is a ground plane on the top of the PCB, there's a ground plane on the bottom of the PCB. And in fact, what I'll do is move that. Where will I move it? Yeah, that'll do. I'll just stick it in between those two locations. So then you can see that the bottom part of the ground plane here is uninterrupted the entire length parallel to those two tracks. So now if I stick another ground there, and I'll stick one there, what that will do is have the effect of stitching, so any return current that needs to follow this track will have a direct path through this, where are we? Rat's nest, okay. So return current related to USB data plus, for example, can pass through the wire down to the bottom layer, and it can follow that ground plane all the way along directly beside the USB plus track and route out through this wire. In fact, what it should do is to have that wire, let's do that. I'm going to move that wire, we'll get some symmetry happening here, move that along, oh come on, stick that in there, okay. Ooh, I don't like that little acid trap in there. I know acid traps aren't really even a thing anymore, but hey, let's be pedantic about it, since this is all about being pedantic right now. So now we have a direct return path on either side of those USB signals from there to there, which covers the vast majority of their length. So hopefully that means that the return current will be as undisturbed as possible. Yeah, exactly. So you said don't get too involved. Chances are it will work fine, but good opportunity for people to consider it when designing. Yes, exactly. That's why I'm going into it now. So as we've seen, it works. I was about to grab the board, but the board is still in the other room. Yeah, so the layout as it was is what's on that board, and it was working. Now I haven't put a scope on it to check the signal integrity or anything like that, but it does work. But this is, return current paths are something that I don't spend a whole lot of time thinking about, except when I'm working on fairly high power circuits. So it matters a lot with things like motor drivers, where you might have multiple amps going through, and it's really easy to end up in a situation where you are thinking about, oh, I've got lots of current coming from my power source into the motor driver, and then from the motor driver to the connection out to the motor. But then you kind of overlook the fact that all of that power has to come back again. And it's really important to think about the return path of the current for the motor driver. So I do put a lot of thought into it when I'm working on things like the water cannon project, where I'm driving big DC motors and I've got fairly high power motor drivers. I pay a lot of attention to the current paths and making sure that there are good return paths as well. But I kind of stop thinking about it when I'm dealing with low power signals. And with things like USB data, it kind of does matter to some extent. So I need to think about that a bit more and not just totally ignore it. So I had totally ignored it on this design. I just routed these traces and not even thought, didn't even cross my mind to consider the return paths on those signals. And the fact that there is, for example, this 3.3 volt rail, which is totally bisecting the return path on the top side of the PCB for those signals. So the signal is on the bottom side, return path could be on the top side, or it could be on the ground plane along beside the signal path. So at least now we have good uninterrupted return paths on both sides of the bottom layer, on both sides of those tracks. Cable tie! Yes! Yes, 4 layers. Okay, so Intermittent said, why not move to 4 layers? Well, I could. Is this a 4? This is only a 2-layer board, isn't it? What? No. 4 layers? This is a 4-layer board. Is it? Is it really? Let's see. Hang on. I just want to isolate. Yeah, I think I might even have a... what do I have? Route 2. I've got 3.3 volts on layer 2. So layer 3, what's that one? That's ground. Oh, okay. All of this, and it is actually a 4-layer board. That's right. I forgot that I'd made the decision to go for a 4-layer board. I hadn't even noticed because everything is routed on the top and bottom layers. There is no there is no internal routing whatsoever. So this is layer, so that's layer 2. In fact, let's go from the top. So this is, yeah, my head's in the way. Let's make me disappear. So this is the top layer, and that's where most of the direct traces are routed. This is the bottom layer. And I'm going to go to single layer mode just to make it clearer. Okay, top layer. Lots and lots of interrupted things there. Bottom layer. Not so many interrupted things. There are some, it's mostly straight paths. V raw goes to there and there. Okay, that's interesting. So then if we go to layer 2, this is a 3.3 volt plane. So this entire plane, this pore, is 3.3 volts. So that gives us a convenient place to pick up 3.3 volts anywhere in the circuit. So you can see that there are a few wires here that are bonded directly to that layer. And then layer 3 is this one, and this is another ground plane. So it goes ground plane with signals on the outside, then a 3.3 volt plane as layer 2. Layer 3 is this ground plane, which is uninterrupted. There isn't a single track on it, apart from pass-through wires and things. And then layer 4 is another ground plane, and it's interrupted by some signal tracks. But okay, so what that means is that this differential, this pair here, this USB pair, is actually bounded directly by this layer, which has a solid path from there down to here, and it's stitched with these ground wires. Okay, so intermittent suggested so Stephen says remove your 3v3 trace and use your wires to the plane. Yes. So why is there a 3v3 trace there? I don't even know. Oh, okay, I think it was just to yeah, that trace there could just go away. Doesn't even need to be there. But it is a short shot here from the output of the 3.3 volt regulator to this point. I don't think there's any particular harm having that trace there. That's fine. That'll do. Okay, so intermittent said maybe switch in 1 and in 2 around, make in 1 ground since it's closer to the top where all the signal traces are. Although your USB is on the back, but it's differential. Yeah. Yes, I see what you're saying. So by in 1 and in 2, what intermittent means is the internal layers. So if we're looking at the stack up, let's have a look at layer stack manager. So with this cross section, is it gonna, no, that's as big as it gets. Okay, so this is typically the way boards are made. Usually there is, well, it varies depending on the factory, and I don't actually know which way around it is. Often there is a layer of copper, then a thin layer of fiberglass, then a layer of copper, then a thick layer of fiberglass, then a copper, thin fiberglass, copper again. What this stack up is showing us is that the dielectric, this layer here, is thicker under the top layer, and then the other 3 layers are close together. But I think it's, as far as I know, it's more common to go thin, thick, thin, rather than thick, thin, thin. So, yeah. Anyway, yeah, this is fine. I don't think it really matters. We're at the point of discussing stuff for the sake of discussing it, and because it's kind of interesting and good principles to follow, but not necessarily anything that is going to control whether this works or not. Because as we've seen, it works with the current design anyway. And I don't think it's marginal. And like, it's not on the border of just working. It should be pretty much okay. So, board thickness 1.99 millimeters. Yeah, this stack up is for a 2 millimeter thick board, and I normally just go for 1.6. So this would probably be, dielectric 2 is probably like a 1.2 or a 1.1 millimeter thickness. So, edit material properties. What does that allow me to do? Don't know. Anyway, back to what intermittent was saying was I could swap. At the moment I've got, going from the top to the bottom, I've got ground, 3.3 volt, ground, ground. Instead I could go ground, ground, 3.3 volt, ground. So that the 3.3 volt rail is separated by a ground plane from most of the signal that's on the top. Anyway, I think this is enough theoretical. All right, let's check out layers. Let's bring the top layer back in again, the T-place layer, because I want to, hang on, why isn't that visible? Oh, I know, because I'm in single layer mode. And I should rip up that. There we go. Okay. So let's figure out what is going on. Well, firstly, let's get this TX and RX sorted. So now we know. Let's figure out how this is being handled. Now, when it sets up the serial connection, which is down, here we go. KO. Serial2.begin. This is the critical thing. So I just want to make sure that what we're talking about here is RX pin and then TX pin. Because you can see up here on the rack 32 I had the TX pin defined and then the RX pin. And this is why I think I actually had it backwards previously. I thought the TX pin was the RX pin and vice versa because I had my begin backwards. I'm pretty sure this is wrong. This should be RX first and then TX first. Does anybody have immediate strong opinions on that? On whether that is correct, because I'm sure people have this off the top of their head. I think it's RX and TX. So I'm going to go for do a quick search. ESP32 serial.begin, and let's see what hang on, TX, RX, ESP32. Okay, so where is the serial.begin definition? It is RX and then TX. Okie dokie. So this is correct. So the RX pin, and this is from the point of view of our device, is the yeah, okay. So from the point of view of our device, I want to get this right and label it for future reference to make it totally unambiguous, as well as unambiguous as we can. So let's look at what the RX pin is, and KO RX pin is pin 2. All right, so pin 2, back over here. Where did it go? IO2 is RX. Okay, so that matches. So our labels on the nets are correct. IO2 is RX. IO2 is RX. Okay, so on here, IO2, which is the bottom, is RX. Oh look, our labels are correct. What? What a fluke. What are the odds of that? Who knows what the probability is of getting TX and RX the right way around? It's one of the mysteries of the universe. So IO2 is RX, and that is RX from the point of view of our device. It is not RX from the point of view of the KO. So that is the KO's TX pin coming in here. So my label of RXI for RX in is correct, and TXO for TX out coming out here, going to the KO's RX pin. So miracle of miracles, it looks like the labels have ended up correct, even though my TX and RX declarations here were backwards before, and now they're the right way around. Yes. Okay, so Wagon Loads makes a very good point. And I've done this before with cut track jumpers as well. So Wagon Load says if you put a 0 ohm resistor between ESP-TX and KO-RX, the net names won't be incorrectly named. Yes. So another way to, so what that would mean is that you'd have a part in the middle, which would be like a 0 ohm resistor, and then you would have a TX net coming off on the left in this case, so that's TX coming from the ESP, and then on the right hand side you could have an RX net, which is the KO's RX pin, and that can help make things less ambiguous. I've done that. You can do it with a 0 ohm resistor, of course. I've also done it with a cut track jumper, like a normally closed cut track jumper that has the track in place in the middle, so that it's basically just like a bridge. It means there's no part to put down on the PCB, it's just a feature of the track, but it means you have two different net names coming off it. So you have one net name on the left and one net name on the right. And if you did need to cut it, you can always cut it, of course. Peter is telling me to go to bed. What? It's 11:45 in the morning. Maybe it's just because of how I sound. Okay, so wagon loads. That is a. Can you make a jumper act as a 0 ohm resistor? Well, effectively, it is. So a cut track jumper. If I stick one down, let's see, if I go for add part, superhouse, where is it? Jumpers, 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 here. So I've got SJ, which is solder jumper, and SJC, which is solder jumper closed. And if I go for SJC normal, I'm just going to chuck this down on here. So this is a solder jumper. Oops, I'm not actually going to do this, I'm just putting it on. Oh, stop that! Get your zoomage figured out, Fusion. So if I put two traces coming off here, and then I'm just going to stick labels on it so we can see what they are. You can see that they are different net names. So we've got net 8 on the left, net 11 on the right, and the cut track jumper is just a feature of the PCB. So here it is down here. You can see it's two pads with a bridge in place already, and you can see that the design rules are saying that it's an overlap because there is that join between the two. So we would have a trace coming in on this side and a trace coming in on this side. They are different net names, but they are physically bridged directly by the track, by the PCB material. So it gives you the ability to have a split net name. Delete group. Where is my jumper? Dancing in the disco, bumper to bumper. What do you want today, Peter? Okay, so to do, change UART pins for KO. That is done, which means that we are now fully done. Now, status LED. Someone was asking if we'd tested the status LED. I don't think I've patched it on the PCB. Did I? No, it's in the other room, so I can't physically check. Yeah, I haven't, but I'm okay with that. So IO0 LED. Hang on. Did that get fixed? IO0 LED. I don't know why, but I don't remember fixing that in here. I must have. That track must have got fixed. Oh yes, I did fix it. I remember now. It was that track right there. No, not there. Where is the LED? There. IO0 LED. Yes, that's right. I did do that. I remember routing that track now. That one right there. Okay, so the LED is routed through to IO0, which is also the snoot button. Okay. Jack's Tech.
Austin's_creations said, I think you just deleted a especially USB flag in the schematic.
Did I? An ESP USB flag. Where did I do that? Oh, Stephen says your USB trace is broken. USB DM3. Ah, did I just do that by... deleting something when I shouldn't have been. USB DM3, that one there. Yes, you're right. What have I done? Can I just hit undo to fix that? Let's see. Undo. Where did that go? I don't know what that undid. Where? No, come back to here. DM. Oh, come on. DM3 and DP3. So those are the ones that are going to the ESP. So they come in here, and where was it? Up USB.
Austin's_creations said IO19 in schematic view.
IO19 in schematic view. Thank you. Which is right there. Okay. Yes, I see what you mean. Okay, I'm going to just undo because where is that? It should be going to there. Oh, there it is. Right there. There's the missing trace. Okay, I'm just going to undo, 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 undo. There we go. It's back again. Cool. Now if I come back to here, we should be all right. What is it that I just undid though? Was it anything important? I don't know. Let's see, do we have any air wires? No, we do not have any air wires. Those traces are in place. I think it was just from messing around with the cut track jumper and the TX and RX. So hopefully there's nothing else that I've screwed up. Alright, so now what I need to do is go to the B-place layer and flip the board. Badoink. Come on. Did it flip? Why isn't the view flipping? Oh. No? I don't know. F is the is flip view in KiCad, isn't it? I thought it was flip view in this as well. Anyway, the point of this was I just wanted to grab this because I want to make sure that this is now correct. So what have we got? IO0 is now the LED. So this is the label that's on the bottom of the PCB. 16 and 17, so CAN TX, CAN RX, and this is now RX. Which way around does this go? 2 is RX and 1 is TX, TXO. Remove those, stick them there. Yes. So, yeah, thank you very much for, oh, thanks, Stephen, SDA to IO5. Yeah, so thank you very much for picking up that, that broken trace. That would have been an interesting debugging job. So piezo I don't think has changed. So, okay, IO0 LED. IO1 is TX out. IO2 is RX in. 4 is SCL, 5 is SDA. I think we're confident on that now. Oh, come on. Why can't I drag that canvas? Okay, I can't move the view. Oh, I can zoom, but I can't drag. Oh, target the cursor, you stupid thing. Okay, so 4 is SCL, 5 is SDA. Piezo, 14. We haven't, I don't think we've even tested the piezo. Where is the piezo? It's right there. 14. Okay, I'm just going to take it on faith that that works. 16 TX, 17 CAN RX. So 16 CAN TX, 17 CAN RX. Okay, I think this is all looking good so far. So that's the label on the bottom of the PCB. What am I doing? Do that and that. I'm just going to set the grid back to 1mm for no particular reason and pour again before I save so that it's saved in a poured state. Aha! Iggy! Okay, time for brunch. Enjoy your brunch with She Who Must Be Obeyed. And does the buzzer need a sound hole going through the PCB? No, it doesn't. It's got the port on this particular buzzer is on the top of the enclosure. This is sitting on top of the PCB and it's just got a hole in the top center of it. I believe that is it. I think we are done. Except for one thing, one very important thing. We need to do this. Just to avoid a bit of future confusion. Alright, version 1.1. Oh, and is it the same? I'll need to do the same in here as well. There. Here. And come on. There. Alright. What's the date today? 19th. Alright, 19th of November is version 1.1. And I believe we are now ready to go to production. Alright, save. But just as a final sanity check, I'm going to switch to PCB view and do a push to 3D and have a quick look around in it. Yes. Oh, Austin has just sent me a link to a buzzer tutorial. So yeah, this is the same buzzer that I've used on many boards. This buzzer is on all of the water truck control boards, and I control this with an ESP32, so I'm pretty confident on that. Now the display, I hadn't even really given any thought to the display. I better check that I check that the I2C pins are correct on that. Alright, so we've got USB 1, USB 2. Ooh! Oh no!
Austin's_creations said I've used that sketch on my recent projects for buzzer control and works well.
Cool. Thanks, Austin. Yeah, look what's happened to Steve. Steve is wearing a resistor implanted in his head. He's now a cyborg squirrel. So, this is the big question. Do we move the resistor or do we move Steve? I think we need to do a little from column A and a little from column B. So what I'm going to do is come in here. Let's do a rip up. We're going to get rid of that trace there. Get rid of that trace there. I'm going to move this and put it there and route from there straight to there. Then I can move Steve slightly and have him clear that resistor. I'm kind of tempted to rotate that resistor as well. I'm not really that fussed. Okay, I'm just going to move Steve, I think, and I'll leave that resistor where it is. So I'll just route from there to there and go, yeah, so we want to go, no, I don't want that. I want to go T-place layer, single layer mode, group select, grab Steve, And then we'll take Steve for a little walk. No, I did not want to move. What? Why is it moving that when I'm in single layer mode? Fusion, you are so screwed. That's just dumb. I'm in single layer mode, selected on T-place, and it is moving those parts. Presumably because they have some silkscreen on their footprints, but oh, that is just dumb. Okay, I'm just going to move Steve down by 1 millimeter, stick him right there. Oh look, I can move these parts by grabbing their origin even though I am in single layer mode on T-place. That is just, that's broken. Alright. So Steve is now clear of those resistors. Then what else did we need? There was something else over here that was bugging me, and now I can't remember what. I think, and this isn't it, but I think I'm going to move that 12 volt DC label up to here.
Scott Miller says frustration 360.
Yep. Then what else? I'm sure there was something else that I had been thinking of doing. So we've got the fuse out the top, we've got the reset button at the top. I think this is just about ready to generate production files. But let's do one. Oh, okay, you know what I haven't done? I have not done ERC and DRC. I really should do that. Errors. Come on.
Austin's_creations said JLC PCB has multicolor PCB silkscreen coming into new year.
Yeah, I know. I saw that. That is really cool. Multicolor silkscreen. That is going to, yeah, there is going to be an explosion of PCB art, I think. People are going to go nuts with it. So what have we got? Power pin, yeah, close but unconnected. Yeah, I don't care. They're not meant to be connected. Power pin on J bus connected. Yep, that's fine. VDD to 3.3. It's meant to be. It's meant to be. It's meant to be. Okay. So let's do. Whoop, we'll zoom in preparation, and we'll do DRC on this. Check. Errors. Drill size. Oh, it's just a whole lot of drill size. Is that all it is? Yeah, there are no other. It's just complaining because my design rules are set to disallow 0.5 millimeter drills. And yeah, these are all going to be set to 0.5, I hope and I think. So I'm just eyeballing them as I click through. If any one of them looks dramatically different to what I expected, no, that's fine, that's fine. Dimension, those overlaps are fine. It's just on the, it's on the weird little slots that go into the fixings for the USB-C connector. Okay, so, past DRC, save again. Wagon Loads asked, do all buttons have easy access?
Said, I knew that spectre of finishing before midday was a fever dream.
They're pretty close though. It's 12:03 and this board is now ready for production files. Wagon Loads asked, do all buttons have easy access or blocked by nearby parts? The snoot button is maybe slightly blocked by the LCD, which I don't think is even going to be installed most of the time. And that's right, I was just going to check. Yeah, okay, so I2C is correct.
Said, did you updated the version number?
I did indeed. It is, whoops, zoom, there, 1.1. All right, so the snoot button is not that accessible, but it also doesn't matter that much. It's got a big connector to its right. It's got the thing over here. In fact, what I can do is, let's do the 3D push again, because that'll make it easier to see all of this. This reset button is, it's a right angle reset button, which is going to be accessible from outside of the case. So I think that's going to be okay. Yep, now Steve is clear of those resistors. Let's go back to the home view. Yeah, so you can see the snoot button down here has this getting in the way. It's pretty clear apart from the LCD. The reset button is a right angle button that protrudes out of the enclosure. So that's going to stick out of the top of the enclosure, and the fuse is also going to stick out of the top of the enclosure. So I think we are in pretty good shape now. Steve is happy, that's the important thing. Yes. Sitting on F1. Oh, that's a good point. Scott says, I still say Steve would have been more comfortable sitting on F1. So what I could do is rotate F1 down here to make it like a little platform and have Steve sitting on it. Oh, that is, it's kind of such a cool idea that I'm tempted to do it. Where does that trace go? There and there. Yeah, what the hell. Let's do that. Let's move that and take F1, spin it. Yeah, about.
Austin's underscore
put it about there.
said super chat.
Ooh, super chat. Thank you. So, hang on. Why am I getting a super chat from Tomo? Steve's looking cramped. Yeah. So let's move Steve. What width is that trace? 508. Okay. Needs an LED eye. Oh, come on. This is becoming more and more complicated. All right, I'm going to route this 50.508. So okay, that to there. 5 volts, 3.3. I'm going to, what will I do? I'm going to get rid of that. Where does the other end of this trace go? Oh, all the way up there. So I'll move this. I don't want that via to be visible. It's the push-pull rules that are, oh, come on. The push-pull rules are stopping me from dragging that via. Okay, now maybe I can drag it. No, not that. I want that. No, not that.
Peter Lawler said, I'm not buying this board if Steve doesn't have a pulsing red eye.
You're not buying this board anyway, Peter. There we go. Okay, so now I want to get this via. Oh, this must be on a. What is the position of that? Okay, I'm just going to change this because it drives me nuts that this is on a 0.5 millimeter offset. I'm going to change that to 11.5 and delete that and that. Does that track? Yes, that track now hits up here. So I'm going to bring this down to there and route from there to there, from there to there, and on the top layer I'm going to route from there to there. Okay, so now we have ourselves a nice little platform for Steve to sit on. And let's see if we can move Steve without moving everything else. Oh no, I want move tool and T-place. Group, I'm going to grab Steve without grabbing those resistors, I hope. Oh, it's grabbing that track as well. Okay, single layer mode. Hopefully that'll fix it. And grab just Steve there. Okay, move. Oh, I should have set the grid to a smaller increment before I did that. All right, we can still do that. Let's set the grid to 0.1. 0.1? Yeah, 0.1 millimeter will do. Now, actually, the other thing is, what I should do is change the footprint, because this footprint, I should have done this earlier, this footprint is actually wrong for the for the fuses that I've been using recently. So I now have a smaller footprint fuse. Where is the fuse? Where's the fuse? It'll be something like this. This fuse here. Let's try a replace on this. Fuses, PTC. Is it the A? No, not that one. 1206. Yeah, it's the 1206 size fuse, not the 1812. So these Bourne style 1812 fuses are very big. Recently I've been using these little 1206 fuses, so let's do that. Replace that with a 1206, and that one also with a 1206, and there was one over here. That one. Okay. Now this has totally screwed up our plans because this fuse now has a much smaller footprint. And now what we can do is move Steve down to the top of that. Now, some of my traces are a little bit messed up because the fuse footprint just got a whole lot smaller. Let's, oh, come on. Let's move that in there so it doesn't have that ugly little jigger. Up there, oh yeah, that footprint has got a bit weird. What? Yeah, that'll do. And up here, where's the other fuse? Where did it go? That, no, not that one. It must be there. Yeah, look at this. This trace has now got weird as well. All right, I'm going to rip that up.
Peter Lawler said version 1.1.1.1.1 underscore final underscore for reals this time underscore yes really underscore look mum no hands.
That is exactly correct. That is how my versioning works. Ah, move, there. And route that one to there. Okay. Now, underscore for reals this time. Oh no, I should have poured the polygons before I saved it. Oh, Ray. Okay, good night. Now, I've got to remember to pour the polygon before I save. Otherwise, it doesn't get saved with the polygon poured. And now I can push to 3D again. Push. And we will see what happens down here. Is Steve going to be sitting on a fuse? And the fuse should be smaller, so it'll be a little platform. But no. Oh, there we go. So that F1 that you can see there, that's a designator. It comes up in the 3D view, but it's not actually on the silk screen, so that'll be fine. So we now have Steve sitting on a fuse. All of that messing around. Hopefully it makes people happy. 12 volt DC. I think that's it. I think we're done. As in, well, this live stream is done. So those, ooh, the spacing on that is screwed up. Oh, I can't have that. Okay, I need an extra space on the first three on here. So I need to go space, space, space. Is it just one space? Yes, it is, because it's mono-spaced. And then pour, then save, and then I am going to generate production files and call this done. Call version 1.1 final underscore for reals this time is going to be done. All right, so where are we? Manufacturing. Let's do manufacturing. CAM processor, and I'll grab my standard 4-layer job. Export as zip. Yes. What the hell? Where am I gonna put it? I have a folder specifically for Gerbers. So Dropbox. Gerbers. there. And I'll get rid of that from the file name, save, open folder. All right, so we now have production files. And that's it. I'm going to send this to production. In fact, just to keep me honest, here we go. Here's JLC. And I'm going to go, come on, sign in. Why do I need to sign in? I should always be signed in. Where is it? There. Bring that over there where I can see it. And order now. Yeah, why don't I have stuff in the cart? I should already, oh, maybe I don't. I have a an order currently in production at JLC, which is almost finished. But yeah, I thought that I had some boards queued up in my shopping cart already, but I don't. So this is going to be the start of a new order. I do have several boards that I need to order for clients as well, so I'm due to put an order in today. Hassle, let's get a stencil. What the hell? With a frame? Yes, what the hell? Top only. Fiducials.
_creation
I fetched.
said, should add the app to this order.
Add the what to this order? Add the, oh, the AP. Yeah, except that one isn't designed. That's a long, long way from being designed. There's a lot of work required there. All right, so what have we got? $34, and then shipping is $60. Shipping has gone crazy recently. See, this is, what is the minimum? So it's 5 PCBs and a stencil is going to come to 95 Australian dollars. And a lot of that shipping is actually because of the stencil, unfortunately, because I'm going for a framed stencil. And so if I was just doing this for myself, in fact, should I order the stencil at all? I'm only going to be making like 3 of these. So I'm going to take the stencil off. Let's see what it does to the shipping. Okay, shipping went from $60 to $30. But the thing is, yeah, so the total price now is like $48 to including shipping to get 5 of these boards to me. So yeah, nobody else is ever going to care about this PCB. There's no point ordering more than a 5-pack. So Austin says, I order it normal and custom sized. Yeah, and Cable Tie says, yes, the frame stencil makes the volumetric price factoring come into play. Yes. Oh, there's another Henrik. Henrik from Denmark. Welcome. So we have a Henrik from Estonia and a Henrik from Denmark. And Scott says, how many times do you need to save that $50 to make it worth owning a small laser cutter? I have a laser cutter. I just don't have a laser cutter that will cut stainless steel. So I can very easily make my own stencils out of plastic. And the thing is that I've got so used to stencils with frames that anything else just feels like a pain in the ass now, because the frame makes it so much nicer. All right, so, okay, the logic here, the logic. I need to order some boards for some clients. Those boards are definitely going to have stencils ordered with them, and they're going to be framed stencils because they are going to be used a lot. Like we're going to be doing production quantities of those boards for that particular client. What that means is that the volumetric shipping is going to kick in anyway. So the difference between one stencil and 2 stencils is not that much. Once you've got to the point where you're ordering a framed stencil and you're paying the premium on the shipping, might as well add more stencils to the order. So I think what I will probably do is I am going to go, but can I bring myself to do it? It's like an extra $40 when I could do it with a syringe, and I'm only going to assemble a few of these. Wagon Load says, can't you 3D print the solder paste? No, I can't. I did experiment with putting a solder paste dispenser on my homemade pick and place machine, but I never actually got it working properly. It's also very, yeah, they're very finicky. Stencil, I'm going to leave the stencil off for now, off this order, because I am only going to make a couple of these. I think probably at most I'm going to assemble 3 of these boards, 1 for each of my pick and place machines. So I'm just going to leave it like that, a 5-pack of PCBs only, no stencil, and save to cart. So then before I actually submit this order, I'm not going to submit it right now. I'm going to have to do a bit more work on a board for my client, generate production files for that, and then add that to the order as well. Yeah. Celtic Beast says, no, get a stencil, order with client stuff. And in a minute says, for me the annoyance without a stencil often already doesn't make it worth it, and I just order a stencil. Oh, Wagon Load says, does this board have ability to be a wireless USB hub now? Maybe. That is quite possible. We have an ESP32. Okay, cancel that. We have an ESP32 connected to a USB hub, so it could probably do it. Yeah. Oh, connected to the wrong hub pins to allow that to work, Austin says. Okay, so it's not connected to the upstream pins. Yeah, okay. Yeah, that whole wireless USB hub idea is kind of interesting as well. That's intriguing. So, I do believe that's it. Hang on. Because it's complaining about documents being out of sync, I am going to push that to 3D PCB again. Push and save the 3D document just to make sure that everything is in sync and saved. And also I want to see the spacing on the text here. Jump back to where it should be. There we go. So now all of that is lined up. Okay. That's it. That is the OpenKO board, and I have a fair amount of faith that it is actually going to work this time. Saving. Alright, saved. And Autodesk Fusion quit. Alright, it's doing its save and upload to the cloud thing. We'll let it finish. Okay. Oh, Johnny says JLC PCB is $25 DHL to Sweden.
_creations said, did you save your work in Arduino Sketch?
Good question. Did I save the sketch? Yes, I did. Okay, so this is the sketch as it currently stands with the config set to the OpenKO board. So yeah, right now the OpenKO board is the patch prototype is plugged into the pick and place machine. So next time we run a job on that machine, it should be done with this board, which is really cool. Also, I've got to get the CAN stuff going, talking to the conveyor belt controller, because having to put boards into the machine and then take them out again by hand for every single board is at the point now where it's quite annoying. I want to have boards queued up on the conveyor so that I can start a job and then, or more realistically, Tom can start a job and it can bring the first board in and then run it and then take it out to an exit conveyor as well, and have at least a few go through on the queue before having to manually be putting stuff in and out. Hey, Imi is at the drag racing today. So Imi said, hello, Chip and I are at the local drag racing event today. Just wanted to pop in and say hi. Have fun at the drags. Okay, OpenKO, that is saved and quit. And in my shopping cart, I now have the OpenKO PCB. All right, now I have to go because I have to go and meet a client at a facility this afternoon. In fact, at 1 o'clock, I have to be in Doncaster to be doing some testing on a machine that is not working and figuring out what is going on. And I really do not want to be doing this on a Sunday, but yes. Apparently I can't say no. So I agree to things that I really don't want to be doing. But I'm going to go and do it. All right. Oh look, 2 of me. Now only 1. Oh. Brain fade again. Sounds like someone's drag racing out here. I just heard a very loud car pull up. What's it doing? I'm just looking at the CCTV to see if I can spot the car out the front. No, it was probably just someone from the performance car place out the back. Okay. Yeah, time to go now, says Cable Tie. That's right. Half an hour, no, 35 minutes, 34 minutes. I can get there in 34 minutes. So as Peter says, it is time to say bye. Okay, I think we may actually be at the end of this OpenKO project, and we should have a working board really soon. If I place the order this weekend, we may even have boards to do an assembly on the next stream. We shall see. So hopefully it works out that way. In the meantime, thank you all very much for helping with this little problem. You are part of my social engagement and you are helping to extend my lifespan by being here. So think about that. You coming to my live stream is helping make my life better and longer. So you are saving my life. How's that for an obligation to keep coming to the live streams? Okay. All right. I am going to go and check out this thing at the premises over in Doncaster. And I hope you all have a fantastic week. And I will see you all soon. Go and build something awesome. Bye.